Hello and good day. This is Dr. Fredericks, and this is your first video for the course. I wanted to give you a brief introduction as to what these videos are intended to be and what these videos are not. So first off, I thought these videos were a great opportunity to give you an introduction into the statistical analyses that we will be covering in class. I thought there would be a great opportunity as well for you to ponder on some of the concepts that we'll be going over, help you guys to formulate really awesome questions ahead of time. What the videos were not intended to do were to serve as a substitute to reading your textbook. The intention is that the videos will help to complement what is in your text and possibly help to make it a little easier and bearable to read the text following the videos. The textbook was assigned for a purpose. Please do not attempt to use these videos to substitute the readings that are very important, in my esteem, to this class. Thank you and enjoy. Hello again. The video that you're about to watch is going to be focused on the two-way ANOVA. So recently we've been talking a lot about ANOVAs, but more specifically one-way ANOVAs. And for the one-way ANOVA, we're talking about instances in which we are looking at one factor and one dependent variable. And factor is another term utilized in the research for independent variable. So today we're going to be talking about the two-way ANOVA, and the two-way ANOVA focuses on designs in which you have two factors and one dependent variable. And so for example, let's look at the question, what is the effect of temperature and humidity on academic achievement? And so below you have this chart that essentially illustrates hypothetical data that one may have gotten from such a question. And so here this chart illustrates that we have two factors or two independent variables, one being temperature with two levels of that factor, cool and hot, and the second variable, humidity, with two levels of that variable as well, low humidity or high humidity. And so when we talk about factorial designs in the text, you may come across designs being written in numerical form. For example, you may see a 3 by 4 by 2 factorial design. Don't be alarmed. All that means is that we have three independent variables, which is evident by the three numbers that you see, one with 3 levels, one with 4 levels, and one with 2 levels. So for the research question that I talked about previously in regards to the effects of temperature and humidity on academic achievement, one could characterize this as a 2 by 2 factorial design in which we have two independent variables, both with 2 levels each, right? 2 by 2, 2 levels of the first independent variable, 2 levels of the second independent variable. And so in regards to factorial designs, you may hear two terms being utilized to describe factorial designs, one being a balanced design, and that's basically where all cells contain the same number of subjects, and we've talked about that previously. Second is a completely cross-factorial design, and that essentially is where each level of one factor is combined with each level of the other factor. And so to go back to the previous slide, here what you're seeing is a completely cross-factorial design, right? Some subjects were in the low humidity and cool condition. Some subjects were in the low humidity and hot condition. Some subjects were in the high humidity and cool condition. And some subjects were in the high humidity and hot condition, right? Completely crossed. And so when we are conducting a two-way between subjects ANOVA, we are evaluating three different sets of mean differences, two main effects and one interaction. The first main effect is looking at the mean differences between the levels of IV1. Second main effect, looking at the mean differences between the levels of IV number 2. And lastly, the interaction, which is looking at mean differences that may result from unique combinations of a specific level of IV1 and a specific level of IV2. So looking back at our question, our research question, what is the effect of temperature and humidity on academic achievement? Our first main effect would be the mean difference between hot and cold temperature. The second main effect, mean difference between low and high humidity, and the interaction is going to be the temperature by humidity interaction. So let's focus now on the interaction and how that looks and how we graph interactions. Here below I have a chart illustrating hypothetical data. What we have illustrated in the graph is essentially the cell means: 85, 75, 75, 65. Those are the points that are illustrated on this graph. Those points are essentially aligned with each condition or each combination of the levels of your two independent variables. Just by looking at this graph, I can tell that there's no interaction. How you can tell that there's no interaction is when those lines are parallel, right? So if I had to interpret what I'm seeing here on this graph, what I would say is that individuals who experience low humidity in hot temperature achieved higher than individuals who experience high humidity in hot temperature. Conversely, or also rather, individuals who experience low humidity also achieved higher in cool temperature when compared to individuals who experience high humidity in cool temperature. So right now we're just looking at the chart, looking at the cell means and graphing those cell means to determine what the pattern of the data is. So here now, what is illustrated on this slide is an interaction. And I can look at it and tell because I see these two lines converging. Once the lines are converging, they look like they're about to converge, they're intersecting, that's a good indication that there's potentially an interaction there. Well, based on what I'm seeing here, individuals who experience low humidity, regardless of whether the temperature in the room was cool or hot, they achieved the same. The data, of course, represents your dependent variable, which in this case is academic achievement. So what we're seeing here is that achievement was higher for individuals who experience cool temperature than that of individuals who experience hot temperature when the humidity was high. When the humidity is low, achievement is the same between cool and hot. When humidity is high, you see those differences in achievement. If I look here, this is another example of an interaction. Clearly an interaction because these lines are intersecting, right? And so all of this is hypothetical data. And important to note, each of these charts are actually aligned with the graph that you're seeing. So I looked at the cell means, I plotted the data based on the cell means. You also are going to see marginal means here. In this instance, the marginal means are exactly the same. They're all 70. What the marginal means are aligned with are the means for each level of your independent variable, whereas the cell means are aligned with the means for each combination of your independent variables, right? Cool, low, cool, high, hot, low, hot, high. Okay, but when we're plotting the interactions, we're using the cell means, not the marginal means. And so here, you see a shift in the achievement of individuals in different levels of your IV, right? So when the humidity is low, those who are cool achieve higher than those who are hot. When the humidity is high, those who are hot achieve higher than those who are cool. So let's move into null hypothesis testing for the two-way ANOVA. So let's start with a vignette. So most of us find it difficult to think clearly or to work efficiently on hot summer days. If you listen to people discussing this problem, you'll occasionally hear comments like, it's not the heat, it's the humidity. And so to evaluate this claim scientifically, researchers decided to design a study in which both heat and humidity were manipulated within the same experiment and then measured academic achievement under a variety of different temperature and humidity conditions. So this is essentially giving us more information in regards to the research design. Step 1, state the hypotheses. Now again, remember when we're talking about a two-way ANOVA, we are testing 3 different sets of means. Thus, our hypothesis should also represent these 3 different sets of means. So we're going to have 3 null hypotheses and 3 alternative hypotheses. So again, our null hypothesis is essentially stating that nothing is going on, and if nothing is going on, all the means are equal. For our alternative hypothesis, we can state that one level of each of the IVs are not equivalent to the other. Why we can say this is because we only have 2 levels. Had we had 3 or more levels of any one of the independent variables, we would have had to say at least one mu, or at least one population mean, is different. And the alternative hypothesis for the interaction is simply going to state that there is a significant interaction between your 2 variables, which in this instance happens to be temperature and humidity. So step 2, select the statistical test and significant level. So we know that there are 2 independent variables, temperature and humidity. We know that we have 1 dependent variable, academic achievement. No alpha was given, so we're going to assume that our alpha is 0.05, and so the appropriate statistical test is going to be the two-way ANOVA. Step 4, find the regions of rejection. Now, similarly to us having 3 different null hypotheses, 3 different alternative hypotheses, we're going to have 3 different regions of rejection. Why? Because we are assessing essentially 3 different sets of mean differences. So yes, we're going to have 3 F ratios as well as 3 F crits. All right, step 5, we're going to calculate the test statistic. Here I have a two-way ANOVA summary table. So I haven't filled in the data, but I wanted you to see what the two-way ANOVA summary table looks like. So for source, you have between. You then have within and total, like previously, but what you also have is 1 row for the first independent variable, 1 row for the second independent variable, and 1 row for the interaction. Now, if you go or look to the right in the F column, you will see 3 numbers. Those are representative of your 3 F values that you will compute for your two-way ANOVA. So this essentially is breaking down the two-way ANOVA structure. So you begin with total variance, right? If you think about when we compute our sums of squares, we typically start with sums of squares total. So we begin with total variance, then we break that down into the between treatments variance and the within treatments variance, right? And we typically do between and then we subtract between from total and we get within. So what we're going to be doing now is an additional step with the two-way ANOVA where we are dissecting the between treatments variance into 3 different components. Variance for factor A, variance for factor B, and variance for the interaction. This brings us to the end of our two-way ANOVA video. And please come prepared at the beginning of next class for the first 10 minutes as you will be assessed on at least 2 or more of these questions. And if you do need supplemental information, of course, you are more than welcome to open your textbook or use the internet or any additional resources that you feel will be helpful to you getting the best grade on your assessment as possible. So thank you and see you soon.